So I am inviting the next speaker onto the stage. The next talk is the one that I am personally excited to attend. We have Jayesh Sharma from ZML presenting before you his talk on build your own autonomous agent powered by LLMs using Kubernetes. He'll explain how these autonomous agents work and how anyone can quickly create customized bots using open source tools like LangChain and models like Dolly. So let's not go deeper into the discussion of the description about the topic, and let's just hear it from him. Okay, let's throw a large round of applause and welcome him and show him the excitement that we have.
All right, thank you so much for the introduction. Before I begin, let's first establish the context of this talk. So what I'm going to talk about, as she mentioned, is about building autonomous agents using something called LangChain, and we'll use Kubernetes as a way to orchestrate our applications. So that's the entire premise. Let's start off. I am Jayesh Sharma. I work at ZenML as a platform engineer. And what I mean by that is I take care of developing and managing the infrastructure over at ZenML for machine learning applications. So that involves like spinning up clusters, maintaining them, figuring out what is the best approach, what is the best practice for setting up ML workloads and how to scale them. And then I also have a lot of blogs, a lot of articles that I write on the stuff which I work with, and then I make videos on top of that as well. I love open source and love hacking in nature. That is something I'm truly passionate about. And you can find me on Twitter at wjayesh. That's the handle that I use. All right, so coming to the talk, let's figure out what we're going to cover in this session today. So the first and the most important thing is what are autonomous agents in the first place. So we'll drive home that concept. Then we'll look at like various challenges that come on developing these autonomous agents. So like how do you put this idea into code by using what libraries, what concepts. So we'll talk about the LangChain library and how you can use that library to establish these agents. The third step will be talking about the production side of things. So for example, if you still have a LangChain application, but can you deploy this application to production? Basically, can you make this available to your customers to be able to use them as well? So we'll talk about the production side of things with LangChain. And finally, we're looking at a demo using Kubernetes on using ZenML as well. So to begin with, let's talk about autonomous agents. So is there anybody here who has heard of autonomous agents or what those are? Any experience with those before? No hands? Have you heard of LLMs? Oh, there is one, yeah, good. Have you worked with any agents before? Have you seen them in action somewhere? Maybe on demos on Twitter, some other places, like some kind of autonomous agents. Oh, that's amazing. So BabyAGI is one of the examples. So you must have, like, if you go to Twitter over the past few months, you'll see there are multiple demos of people just setting off an agent which works on multiple things and performs certain tasks for you. That is what the autonomous agent is. So just to summarize what agents are, is some systems that can reason as well as act on their reasonings. For example, if you ask it to perform something, it can reason, okay, maybe I need to do these tasks, and then it performs those tasks as well. That is what an agent is. An autonomous agent is nothing but something that can do its work without you having to interfere, without any human interference. That's what autonomous agents are. And some examples, as he mentioned, BabyAGI is one of the examples, Auto-GPT, Agent GPT, all these are examples. So enough of talking. What I'll do now is quickly go to this Agent GPT website. So this is one of the examples. I just want to make you see this in action to further understand what the concept is. I think the net is not. There is definitely a Wi-Fi problem here, I'm thinking. My bad. But that's okay. So what I can do is I can encourage you to go to this website on your own, Agent GPT. And what this does is it has multiple templates. You can see there's a travel GPT, all these things. So when you click on any of these, you can see there's a sequence of actions. So for example, I'll give you an example. Let's say I will tell this Agent GPT that give me a travel plan for Goa, something like that. So what it will do is that the first step will be the thought. Like, okay, the user has asked for a travel plan to Goa. Then it will figure out a certain list of tasks by itself. So the first task could be search for flight tickets to Goa. The second task could be figure out the best hotels to stay in Goa. Third could be what is the best season to go there. So all of these tasks, this agent can figure out by itself. That is the reasoning part of things. So this agent knows, okay, this is the task at hand, and this is the reasoning behind of how to figure out what task to perform. And the second step is to actually perform those tasks. So it will use something like Google Search API or Bing Search API, any search API, to perform each of the specific tasks and then combine the results from all those tasks into the result that you want in a very natural language. So that is what the agent does. So if you have some time, go check it out at some later stage. But that's the idea. So now, how do agents work intuitively? So you have seen, or at least you have heard what agents do and how these things work. But if you think about what goes on in the background, let's just go through this all together. So how do you imagine an agent would work concretely, let's say? So you have something like, say, we are all aware of LLMs, right? So LLMs have been the craze of talk of the town for so long. So what LLMs are, those are basically just language models. So they can interpret, they can understand human language, and they can generate results which make sense to you as a human. That's what LLMs do, right? They don't have any other capabilities by themselves. So now you have LLMs which can understand natural language. What the idea behind agents is this. What if you can tell the agent that, okay, you can perform certain actions, and then it can then just read it in while. So the idea is this. So for example, let's say right now the agents are limited to just talking, so they can't really perform any tasks. But if you give them the ability to perform tasks in some way, then the agent can also get supercharged in a way which can think and then also act on its idea. Right? That is the idea behind using agents. So in traditional software development, how do you communicate to any software about what are the tools or what are the actions that the software can perform? How do you do that? Like, for example, if I have some software, I want to use some other software, what is the interface that I use for that? API, exactly. So API is the thing which links two softwares together. So the idea is pretty simple here. So what we want essentially from an agent is that this agent should have knowledge of certain APIs, basically. So it has knowledge of, say, the search API, some calculator API, some other set of APIs, and then you can just ask the agent, okay, these are the tools that you have, perform this action. Right? And how do you communicate that these APIs are available to the agent? How do you do that? Because an agent, like, there should be some mechanism of making these set of APIs known to you, right? For example, you as a developer, when you work with certain APIs, you have knowledge of these APIs and you work with these APIs. But how do you make the same happen with something like an agent or something like an LLM model? You simply tell it, because since it's a language model, it can understand your language. So what you do is, let's say take this example of a Blinkit API. So for example, if I have an LLM model or any, like, say, it can be GPT-4, it can be some other LLM model, and I have a certain set of APIs, let's say a Blinkit API or calculator API and some other set of APIs which I have. Now, how do I make sure that my LLM model knows that it has these APIs available at its disposal and it can make use of them whenever the need arises? So what you do is you have something like this. So there are two sections to it. So any API that you choose, you have a box which tells what this API does. So for example, in the case of Blinkit, I can say that it orders groceries online. So all I have to do is just tell the model, okay, this is an API, take this API as an input. What this API does is orders groceries online. And the second thing which I tell the model is when to use it, which is super important, because I will tell the model, okay, whenever user asks for, let's say, get me something in this much time, or like get me something for this specific recipe. So just give it some examples. So what we're doing is just basically telling the model, because since it's a language model, you just write to it that this is the set of APIs you have. Each of these APIs should be used in certain conditions like these and similar situations, and what this API does. So all that is all you have to transfer to the basically LLM, right? That is the intuitive idea behind it. We are not talking in any concrete form, no code yet, just intuition, just a way to drive home the idea of what agents are and how they work. So you simply tell the APIs, simply tell the model what the APIs are. Now let's talk about more concrete terms. Like let's get out of all the ideas and intuition. Let's maybe put all of these things into different blocks. So far whatever I've talked about can be distributed into 3 different blocks. So there's the first block, which is the LLM, which is the model itself. And you can call that as the first thing, so LLM model. The second thing could be the APIs, which are the tools that we discussed, like the search API, let's say the calculator API, whatever the, or it's just asking people to go back to the classes. Sorry for disturbance. So yeah, so all of these feels like the recess is over, I think. Anyways, yes, these are the 3 different blocks that you can think of. So LLM model is the first one. Second is the set of tools that you have, and the third is the orchestrator. Now, what is an orchestrator? Orchestrator is the stuff, some software which will be communicating between these 2 things. For example, it will take, let's say, the results of the model, put it to the API, because the model itself can't call the API, right? That is not something the model is capable of doing. Model can tell me, like when I ask the model some question, it can tell me, okay, I need to use the search API and perform this search. But it can't actually go and perform that search. You have to have some software that takes these things and then performs those actions on the API, right? That is the orchestrator which you talk about. So just to put it into some more visual perspective, this is what it looks like. So you have an LLM, which is the agent, the GPT model, whatever model you use as an LLM. You have a set of APIs, and these APIs also contain like directions on when to use them, what they do. And there's this orchestrator, which is a simple application, nothing fancy. Just takes the output from this, puts it into there, takes the output back from the APIs, puts it back into the model. So that's how it communicates between these 2 different blocks. So far, any problems understanding the concept or how the agents work? All good? So this is the like basic understanding of how these things work, how like data is transferred, and how an agent can actually perform applications by itself. All right, so now we went from intuition to actually some concrete ideas, and now let's go from the concrete ideas to actual code. So now we talked about 3 different components: LLM, the certain set of APIs, and the orchestrators. Now we have to think of how to actually put them into code. So you have to have some certain set of abstractions, certain set of classes that you can use to actually represent each of the different blocks in actual code, right? So for that to happen, we need some kind of a framework. Why do I talk about a framework? Now, who here is familiar with the idea of a framework and a platform? So what's the difference between a framework and a platform? What do you understand from that? Any guesses? So when do you call something a framework? When do you call something a platform? Any thoughts? Yeah, good. Yeah, maybe the one in specs here last year. Yeah, you got the point, right? So the thing is very simple. So framework is something that doesn't have any opinion. So framework allows you to build things. So for example, let's say if I have a framework, and if I have, let's say, a framework to build an ML pipeline, then I'll have abstractions instead of opinions. So basically, I have one abstraction for, let's say, LLM model. Now this model can be anything. It can be a GPT model, it can be, say, Cohere model, or some other provider for the model, right? But when you look at a platform, let's say OpenAI has a platform. So that means the model, the implementation of the model is fixed. So you only get GPT models. You can't get some other company's model, right? So that is a platform which has an opinionated set of tools which you can use. But a framework, on the other hand, allows you the option to easily swap with different implementations for a given abstraction. So that's what we need when you're developing something like that, because at the early stages, it's very experimental. You have to switch between different models, figure out how to work with them. So the first step that we choose to actually build something like that is choosing framework. So LangChain is a very popular framework. So what it does, it has multiple abstractions for all the components that we talked about earlier. So if you look at LLM model, which is the first component that we had, it has an abstraction for that called agents. So agent is just a class in LangChain, which is an abstraction over LLM model. So it performs some convenience features and some other stuff, but it's essentially a wrapper around a model. That's what it is. It's just a class. Then you have APIs, which we've talked about. That is represented by something called tools, which is also a class in LangChain. We'll be looking at that when we go to the code side of things. But I'm just trying to map these concepts, these different blocks, into actual classes in code. That's what I'm doing right now. So all of these on the right side are classes in LangChain. And the orchestrator which we talked about is an agent executor. Again, don't go over the names, just some representation of what we want to achieve through certain classes in LangChain. That is the idea. So why LangChain? Because it's a framework, first of all. And second, it has multiple implementations of these different components so that you can just get started with it. So you don't have to actually implement any of the blocks by themselves. You also have multiple implementations. We'll take a look at that as we go. But that is the idea. Any doubts so far about what LangChain is? It's too short for a full introduction to LangChain, but I think you somewhat get an idea of what LangChain is. Essentially, it's just a framework to implement certain LLM applications. That's what it is. But you can go over the documentation later on if you have some problems. Yeah, go ahead. Train the agents in what way? Yeah, we can't do that using LangChain itself, but you have to have some other pipeline to build it. Like for example, ZenML offers you the entire structure. ZenML is also an open source library, but it's like one step above LangChain. So LangChain is specifically for language models. So it has abstractions for models, tools, and all those things. But ZenML itself is a full ML pipeline abstraction. We'll talk about that. Like when you go to the course, I'll show you the exact things. This is maybe the next slide as well. So again, LangChain alone is not enough. So what LangChain is, it's just a language framework. It allows you some abstractions to perform multiple actions. But it is not enough for two reasons. First of all, you have to think of deploying this to productions at some point, right? So for example, let's say I developed a LangChain application. A lot of people do that. They make demos on Twitter as well. But those demos run well on a local system, but they can't really scale to the cloud. For example, let's say if I design an entire solution and run it on my machine, it runs perfectly. But what I want is this to be running on the cloud somewhere, and then serving some endpoint on some model someplace as well. So all of that, if you want to enable all of those features, you need additional features on top of that. For example, let's say caching, logging, monitoring, so the traditional stuff that we expect in a deployed environment, right? So all of that should also be a part of your solution and not just the language model part of things. So this is LangChain by itself is just the logic behind managing and controlling a model, but the entire process of going from, let's say, your computer to production involves many other steps. So for that, you need maybe a higher level of pipeline. As you mentioned, like if you want to train the model, if you want to perform any other tasks which are not just relevant to the model. Let's say I want to create some kind of database for the model to work on. So now that should be a part of some other pipeline, right? So you need some kind of a overarching pipeline that also covers LangChain in one of the steps, but it should also have other steps and should also enable multiple other things, right? That is the idea. So exactly what I said, what we need is a high level pipeline. So right now we only have a LangChain thing, which solves the problem really well. So you get a LangChain application built, it uses the models, it uses the APIs, all of that stuff, that works perfectly. But what we need to orchestrate this on the cloud is a high level pipeline. So again, what should this pipeline achieve? Right, so we have gone over this already, but I want to emphasize more on the requirements that such a pipeline will fulfill. Right, so what should this pipeline achieve? So if you talk about any pipeline in DevOps or any other field, a pipeline, the first thing that you can think of when you think of pipeline is automation. Right, so what is a pipeline essentially? Like anybody can quickly give me an idea of what a pipeline is in very simple terms. Yeah, go ahead. Building a deployment, yeah, it enables deployments, but not exactly that. Exactly, a series of steps. Basically, that is all a pipeline is. Pipeline is a series of manual steps. So why do you build a pipeline? So that you don't have to perform the task yourself every time. Right? So for example, if I have certain series of 10 steps, if I perform 10 steps to achieve certain goal, if I automate all of that into a single pipeline, then I just run the pipeline every time I want to perform those tasks, right? I don't have to do them manually, run all the commands by myself, or basically that is the idea, right? So that's one of the applications of pipeline is that. There are multiple other applications as well. You can also have a script in that case, but a pipeline enables this thing to be run automated as well. So what we need is a high-level pipeline which will enable automation of all the tasks that we perform to get our model from local to production. So automation is definitely one of the first requirements that this thing will satisfy. Then there's caching. Caching is super important because let's say if you have 10 steps and then you modify something in the 7th or the 8th step and you run the pipeline again, you don't want to run the first 7 steps all over again because it will consume resources, it will take some time. So what you also need is something called caching, and that will easily help you and ease your development flow as well. So caching is one thing, automation is one thing, reproducibility, as I said, like if you want to run this pipeline again, maybe tweak some parameters, you should have the capability to do that really quickly, and visibility into the steps as well. For example, let's say I am a developer of an ML application and I have a platform engineer in my team. So if I have designed the entire thing in a pipeline, I can easily show the steps to any other person, they will understand what the pipeline does. So let's say the first step is create this, second step is that. So without looking at the implementation of each of the steps, you still have a very clear idea of what the system is trying to do. That is the idea behind a pipeline, right? So this is why we need a higher level pipeline to cover all the concepts together. And additionally, if you have a pipeline and if you have a tool which enables you to build such a pipeline, you should also have some additional parameters, which is first of all, tracking of artifacts. What I mean by that is, let's say if you have one of the pipeline runs and it produced some artifacts. By artifacts, I mean some outputs here and there. And maybe you ran it again at some other stage in the day and produced some new artifacts. So what you want is a way to version these artifacts. Okay, this was the run from the morning. This was the next run which I ran in the afternoon. So all of these should be versioned in some way. So all of these benefits are just additional things on top of a pipeline. So you expect this to be part of a tool or a part of a solution when you're building a production grade application, right? That is the idea behind it. So you just don't just need something which is experimental, that I just run on my notebook every time, then I keep track of it in some other way manually. You don't want that. You want something that is tracking by itself, tracking artifacts by itself, right? That is one thing. Control over scaling of workloads. This is also a super important requirement. You can imagine something like a very complex pipeline which has multiple steps, and each step has different requirements. Let's say one step is very GPU intensive. Other step is very simple, maybe just downloading something from the internet. So you have to have capability in such a way, your pipeline should be so flexible that every step can run on certain different workloads. So you should have that capability in mind as well. So all of these are just requirements I'm going through one by one. And the last thing is flexibility in choice of tools. So for example, you need to make sure that whenever you are using such a pipeline, you should be very easily able to swap the different steps together. For example, let's say if I'm using the GPT model or some other step, and I figure out this step is not working for me, then it should be very simple for me to just change the step without disrupting the entire pipeline. Right? So all of these are requirements of a pipeline that I feel are important for a production grade setup. And one of these steps should also be the LangChain step, of course. But this is the overarching pipeline I'm talking about. So ZenML is one tool which is an open source tool which you can use for such things. So ZenML allows you to define pipelines in Python itself. So a lot of ML applications are built in Python. And what you can do with ZenML is just a library you can pip install ZenML, and then that will allow you to define certain steps in your code. So what you have to do is just annotate any function, any Python function with a @step decorator, and then that will make this as a step in pipeline, basically. And then you can define a pipeline as well. So all of that enables you to define a pipeline in such a way that the execution environment is independent of the code. So when you define the code, you don't have to worry about where this code will run. So that is taken care of by ZenML. So you can just set different stacks, different environments, and then run the same pipeline on any environment you want. That is the idea. So ZenML is one tool that we're going to use right now as the overarching tool for creating this pipeline using LangChain in one of the steps as well. That is the idea. So far, any doubts on what this idea is, why there are two pipelines, and any confusion over the abstractions that we're talking about? Exactly, I said MLOps framework itself. So LangChain itself is just like a language framework. So it deals with LLM models, it deals with any concepts that are specific to the language model. Let's say the tools that I talked about. Prompting is one of the other classes that they have. So they have agents, they have tools, they have agent executor, they have prompt templates, all these things. So whatever abstractions that they have are very specific to the use case of LLMs. So you can develop any LLM application using those things. But as I said, if you want a full solution, if you want everything to go from scratch to a production environment, you need some other pipeline tool as well that incorporates more concepts than just the LLM part of things. That is where we use something like ZenML, right? That is the idea. Any other questions so far? Good. Yeah. A single, what you asked is, do you operate this on a single set of data or bulk data? So this depends on, it depends on your use case. So this is like, it doesn't have any opinions, this pipeline. You can define the first step in any way you want. So you can either stream from Apache Spark, you can stream from S3 bucket or whatever other option that you want. So it doesn't really matter like what your choice of thing is. Like the implementation is up to you. So it just allows you to define a certain way of moving through different steps. Yeah. That depends on the dependency. Maybe I will talk about this after the session because maybe let's more technical detail after that. So don't want to keep up other people waiting. Yeah, so we talked about the pipeline. Now let's talk about where we'll run this pipeline. So we have designed this pipeline in ZenML. We have these multiple steps, and then we have like the LLM application as well as part of it. But where do you orchestrate? Where do you run this pipeline exactly? So for that, we use something called Kubernetes, of course. So what Kubernetes does, it offers multiple benefits. That is why we choose this thing in the first place. So one of them is, first of all, pod affinity. So let's say I mentioned that maybe some of my steps will require GPU, some of my steps will require some other kind of nodes, right? So all of that can be enabled by using pod affinity. So I can make sure that certain pods are on certain nodes or some other specification as well. So that is one of the benefits that you can use there. The second thing could be resource limits, because let's say if you are building such a certain application in production, you need to make sure that it doesn't exceed certain limits that you have set for your environment. For example, if your platform team doesn't allow you to consume a lot of resources, the one way to ensure that it doesn't really cross the thresholds is by setting resource limits for every namespace or maybe on a pod level, whatever suits your benefits as well. Then there's metric tracking, because let's say when you have enabled a production environment and let's say you have a model in production which is exposed at some endpoint, you want to make sure how many queries are answered per second, because let's say you have a GPT-4 model which is being served, right? And you understand that GPT models are not free. They charge you per API request. So you need to make sure how many requests are being made per your application. For example, if you design an application which is not really efficient, which is making a lot of LLM calls, that is going to cost you a lot of money. But how do you figure out you're making so many calls? You have to set up monitoring in the first place. So what you do is you track that for every run of this application, how many calls are being made to the LLM API? How many calls are being made to the OpenAI? How much is it costing me per call? All of that needs to be tracked as well. So that can also be enabled using something called Prometheus. Pretty simple. You can set up Prometheus and Grafana dashboards, and that can track the model endpoints to figure out if you're not exceeding your budget as well. So all of these are additional benefits that are brought to you by Kubernetes and the power of Kubernetes. And the last very important point is also about deploying tools and applications. So anything that you need to use with LLM applications, let's say vector databases or any other helping tools, all of that can be also deployed on Kubernetes itself. So what usually helps is that if you have everything in the same cluster, you don't need to expose anything to the public internet, which is also super helpful. So all of these are benefits that Kubernetes brings. I think I missed one, which is running pipelines on a schedule. And that's also super important. For example, if you have something, let's say, the example which I showed also has something like that. So let's say if you have a tool if you have a pipeline which is really sensitive to the time data, for example, let's say if I have a tool which is answering questions based on some specific documentation, and if a new version comes out for the tool, how do I update my model to answer the questions based on the new version of data? So for that, I need a pipeline which runs on a schedule. Maybe every Friday or every release day, it runs on schedule and performs those actions. So what I need is also something like a cron job, basically. So all of these features are enabled in just a single tool, which is Kubernetes. So what we prefer is that our pipeline runs on this platform, Kubernetes. And how we do that, I'll show you in the next steps now. So this is the example pipeline which I'll show you right now. So it has 4 different steps. So the first step is the URL scraper. So first of all, the application which will show now is an agent which can answer questions based on your documentation. So let's say if you have a tool, like let's say ZenML or let's say Node.js or any other tool that you want, any developer tool you can imagine, and that tool has some documentation that you can refer to. And you want an agent that if you ask that agent some question about the tool, it will figure out how to answer that. So for that, the agent needs to have knowledge of the tool in the first place. So it needs to read the documentations. And in this case, it also reads the Slack messages from the Slack workspace. So let's say if I'm looking at ZenML, So ZenML Slack has a lot of messages from previous years, from previous months. So what I want is an agent that can read those messages, that can understand what the previous context was. It can read the documentation pages of all ZenML pages and then answer a question if I ask anything specific to ZenML. So it doesn't need to always answer about ZenML, but the agent needs to be aware that, okay, I have knowledge of ZenML. So basically what I'm doing now is I'm giving this one API to this agent. I'm telling that agent, okay, you have knowledge of ZenML, take this entire thing. And if any user asks you about ZenML or asks you a specific question about ZenML, use this thing to answer that, basically. That's what I'm telling the agent to do. So for that to be enabled, I have a pipeline which looks like this. So what I'm doing here is simple. I'm using, like, basically until the third step, what I'm doing is creating this database for the agent. So what an index means essentially is just a vector database. So don't worry about the naming here. So what index is just some kind of a database that has vector representation of all the data that I have. So data from documentation, data from Slack messages, all of that is vectorized into different columns, and then I'm putting that into some kind of vector database. And that forms the base using which the agent will answer questions. That is how we represent data in LLM terms. For example, if you have huge swaths of data, you can't just load everything into the context because the context limit is fixed. So whenever you look at GPT models, when you look at other models, when you provide the input to the model, you have some kind of context window. So you can only provide certain number of tokens to that agent, right? So you can't provide the entire documentation. So what we usually do is we store everything in some kind of vector database, and then by using things called similarity searching and other techniques, we extract the relevant parts from that entire vector database and only feed that as context to the model. That is the extra flow which I'm sharing with you. You don't have to worry about how this entire thing works. But just for those who are curious about how this works, that is the idea behind it. So what this pipeline will do is every time I run this pipeline, it's going to generate that vector database. So basically the database which forms the memory, which forms the core of this agent. So I want that every time a release is made with ZenML, so let's say every Friday we release something. So every Friday this pipeline should run. It should extract everything from the URLs. URL refers to the documentation URLs, by the way. So all our pages that we have on ZenML documentation, it should scrape those URLs, load everything from the web into certain documents, and then the final step should get an index out of it. And then I'll use that index to create an agent, basically. So this agent will be using that index as a base to answer my questions. And the final step could be just deploying that agent. This could be on Slack. We already have a Slack agent deployed. Or you could also deploy it on WhatsApp or many other places. You can also deploy it on some endpoint, some website, whatever you want. So basically, until the fourth point is which is important. The last step could be anything that you desire. So that is the idea. Now let's jump into code. Maybe I'll take some water break. Any questions so far? None? All right. Okay, now let's spend some time on the code as well. So I'll zoom in a bit to make this more visible. Works? Okay, perfect. What I'm doing now is simple. So as I mentioned that we use ZenML to define pipelines in a way, and in a Python native way as well. So what you have is something called a pipeline decorator. So if you look here, this is a pipeline decorator. All I have to do is just define a function in Python and then annotate that function with this pipeline decorator, which will term this as a pipeline in ZenML. That's how it is. And now if you look at the steps, it's also pretty similar to what we saw on the graphic earlier. Yeah, what we saw on the graphic earlier. So it has certain way in which we map these steps into each other. So for example, let's say the first is the URL scraper, the first step. It outputs something called the URL. So basically what this step does, it goes through the entire documentation. So let's say my main page is docs.zenml.io. So I don't want to manually enter every sub page into this thing, right? I'll just give it a entry level, like this is docs.zenml.io. The URL scraper will figure out all the URLs which are emanating from this specific domain, basically. So the URL scraper will give you a list of URLs as an output. And now when you have a list of URLs, the second step will be loading the content from these URLs into some certain set of documents. So the second step is that. And you can see how the linking is performed. The linking is performed through the outputs and the inputs, basically. So I just take the output of the first step and put it as input to the second step. So this is enough for ZenML to then create the DAG out of it, basically. So all you do is just define the different steps and you map these different steps using the different outputs and inputs, basically. That's how the entire graph is constructed internally. So you have a URL scraper which lists different URLs as an output. Then you have a web loader which loads this URLs into documents. The third step is index generator, as I said, which generates a vector database out of it. And the final step is the agent, which creates an agent based on this vector database. That is the idea behind the entire pipeline. So as you can see here, there is no implementation. It is just a structure. So what I'm doing is just defining a skeleton of how the pipeline should look like. And now this offers you a lot of flexibility because every step here can be a different implementation. For example, in the future, if I want, let's say, a different index generator, all I have to do is when I instantiate this pipeline, I'll provide a different index generator as an input. So basically, if you see the pipeline definition here, you're taking all these steps as input to this function. So whenever you instantiate a pipeline in the future, you can just replace any of the function with any of your implementation in the future. So that provides very framework approach, or provides very modular in which you can switch between different implementations as well. That is the idea behind it. Now let me go over the agent first of all, because that is the most interesting part. So how do you create an agent? So if I scroll down here, so this must look familiar to you at this point. So what I need to create an agent is first I need to define some tools, right? So I need to tell the agent what tools you have access to. How many time? So what time? Okay, so maybe what I'll do is, I'm sorry, I think I missed some time. So we'll maybe look at the code later on. I'll just quickly run this pipeline so that we have some idea how this looks like. Sorry about the time limit. I did not take a look at that. So what I want to show is basically this agent, this entire pipeline will run on Kubernetes essentially. So what we do is use ZenML to set Kubernetes as the active stack. So if I go to the ZenML dashboard, you can have that as a open source as well. So everything I talk about here is open source. So if you go into your dashboard, you can look at different runs. So I've run it in the past before as well. So you can go to any of these things, you can click on the pipeline run. This will give you a visual of how this pipeline runs. So the first URL scraper, then there's a web loader, all of these steps are there, and the last is the index generator. This is how it looks like, and you have multiple stacks here. So every stack defines where your pipeline runs basically. So I have an Orbit stack which runs on Orbit. I have a Kubernetes stack which runs things on Kubernetes, all that stuff. That's how it looks like, and I wish I could show this to you on Kubernetes as well, but I think since we are out of time, I maybe not do that right now. Let me see if I actually run that. Yeah, didn't run it right now. But that is the idea behind it. So essentially, what we have done is just create a pipeline, and then we are running it on Kubernetes environment. Basically, that's the idea. That's it, I think.
Thanks, Jayesh, for the session.